In this video, we'll be covering dealing with missed or deferred payments when someone takes out a loan and they miss out a certain portion of the duration of the loan, maybe 4 or 5 months of not paying. What happens to the loan, and really what happens in that sense, whether you need to reevaluate how much monthly installments you pay or how long the loan will now become. So we'll be dealing with those dynamics. So let's consider this question. The father decides to buy a house for his family that costs 800,000. The cost of the house. He agreed to pay monthly installments of 10,000 on the loan, which include an interest of 14% per annum compounded monthly. The first payment was made at the end of the month. That doesn't make any difference because now we're doing a present value really. And in present value, we're going to adjust that accordingly if ever we needed to. So the first question says, show that the loan will be paid off in 234 months. Means that's the duration, or N. So far we have everything because you're dealing with present value. It's important that we write down the formula for present value. So it has to be entirely aligned. This will be 1 minus 1 plus the interest, the power of minus n, and everything divided by the interest. So what do we have? We have present value, which is 800,000. That's the loan amount, equals to 10,000, which will be the monthly installments. 1 minus 1 plus the interest is 14%. 14% divided by 100 is 0.14 divided by compounded monthly 12 to the power of. We have to prove that it's minus n, which is in months. So we need to calculate what that n is, and the I is 0.14 divided by 12. We know 800 is divided by 12. We just need to cross multiply. I think now we're getting the hang of this, because with future value and present value, we need to know the skill very well, because you may substitute the values correctly, but if you're unable to manipulate the equation, you won't be able to solve for what we need to solve for. So now our key focal area needs to be, how do we calculate our n? So we're going to divide both sides by 10,000. Then we're going to have 800,000 times 0.14 divided by 12 divided by 10,000, which is equals to 1 minus 1 plus 0.14 over 12 to the power of negative n. I'm going to continue solving for n. Might be a lengthy process, but it will be worth it. So what I'd like to do is a quick hack. You can see that this is minus. So I'll like to take this to the left hand side and bring everything to the right hand side so that it's 1 minus everything on the left. How would that look like? We will have 1 plus 0.14 over 12 to the power of minus n is equals to 1 minus 800,000 times 0.14 over 12, 10,000. And remember, what are we looking for? We're looking for the n value. Remember our logs, where we're given an exponential y is equals to a to the n. When we're looking for n, we're going to say the log of the base of a is 2y is equals to n. We're using the same principle here. In that, now it's swapped around the other way, which means it will be n, which is the exponent, is equals to log the base a is to y. Let's do that. Minus n will be equals to log the base is 1 plus 0.14 of 2, 1 minus 800,000 times 0.14 over 12, all divided by 10,000. And n will be equals to, when I punch everything into the calculator, I get a value of negative 234, but when I multiply by negative, it will be positive. So which means final answer is 234 months. Remember, we were showing or we were approving, so we do approve that the loan will be paid off in 234 months. So we prove that to be true. And how are we going to answer the second question? Second question says, suppose the father encountered unexpected expenses and was unable to pay installments at the end of 124th, 121st, 122nd, and 134th. Means they missed payments for how many months? For 4 months. They missed the payment. At the end of the 124th month, he increased his payment so as to still pay off his loan at the initial 234 by 111 equal monthly installments, meaning the 111 is the remaining monthly installments in the loan. So how do we go about answering? Before he stops making the payments. So we need to calculate the outstanding balance before he stops. So when do you stop? He stops at month 119. So we need to get the outstanding balance at month 119, which means our N will be equals to 119. Remember, outstanding balance, accumulated value of loan amount, minus the future value of the monthly installments. So let's calculate that. We know that this will be 1 plus I to the power of N minus the future value, monthly installment, square brackets, 1 plus I to the power of N minus 1, all divided by interest. Well, let's just substitute all our values. Let's not forget our principal amount there. Our principal amount, remember, is 800,000. 1 plus our interest, 14% divided by 100, which is 0.14, all divided by 12, and our N value is 119. We want to know what the loan value is at before he stops paying, and our X value is 10,000. 1 plus 0.14, all divided by 12, and we're using 119 minus 1, and our interest is 0.14, all divided by 12. So what will our outstanding balance be? Outstanding balance, when you punch everything into the calculator, what I'm getting when I calculate in my calculator, I'm getting 629,938. 11. It means before he stops paying, he still has an amount of 629,938.11 that he needs to pay. So what happens then is when you miss payments, right, of loans or whatever payments you need to make, that loan amount, when you're missing it, it does not remain as is. It earns interest. That amount earns interest for the duration that you don't pay. So we're going to take the 629,938.11 times 1 plus the interest, still the same interest, over 12, and it, remember, it didn't pay for how many months? For 2 months, 4 months. So it earns interest over 4 months. So now the new amount that he needs to pay, 659,853.68. So you can see that the loan interest increased from 629 to 659 by over 30,000 by missing an installment. So, but remember, he said he still wants to adjust his monthly installments so as to catch up and still pay out his loan amount in the initial duration. But they say now he wants to What they're telling us that he wants to do it in 111 equal installments. So how do we calculate that? How do we calculate this new installment? So remember, using present value. This is the loan amount he's owing. You go to a present value formula, substitute a present value. We want to calculate our monthly installment, which is x, square brackets, 1 minus 1, 0,14 divided by 12 minus he wants 111 equal installments over 0,14 over 12. So what are we solving for? We're solving for x. So if you solve for x, you'll see that after doing all the cross multiplication of this and that, 0.68, these will multiply. This will be divided by 1 minus 1 plus 0,14 over 12 to the power of multiple 1. You'll see that you punch into a calculator now, you get the x value of 10,632.39 will be the new installment. As you can see, the installment jumped by only 632.30 because the initial installment was just 10,000. So by then we would have answered this question that eludes a lot of learners. Please be sure to rewatch this video, go step by step and see how to answer this proficiently.